Okay friends, so after studying all the identities of different types in trigonometry, we are now going to start with the questions based upon the proofs in trigonometry. We will be dividing our questions into two parts. The first part will be the study of those questions in which either we will be finding out one trigonometry ratio using another one, or we will be proving some identities in the chapter. The first part would be the proof part. Now to understand that, you will see that students feel that this part of the chapter is very difficult. Why? Because they feel that they do not know when to apply which identity to be used under what situation, under what condition, and so on. All such questions will come to your mind. But in our discussion of this part, you will come to know that it is not that we do not know the trigonometric identities to be applied in the sums. Actually, we lack in our basic arithmetic knowledge. We do not know the expansions of many identities. We do not know many of the other algebraic identities that are going to be used in proving the questions in trigonometry. So first of all, before we start that segment of questions, let us first understand some basic, some fundamental identities in arithmetic. And they are, the first one, the very basic one which every one of us know, but still I would like to highlight this. That is, we know what is a plus b the whole square. It is a square plus 2ab plus b square. Mind you my friends, remember the language. It is read as square of the sum. You can see that a and b are added and then its square has been taken. So whenever the square is outside the bracket, it means it is the square of the sum. Sum means addition or total. Second is square of a minus b. Now whenever it is minus, you know what is called as, in mathematics it is called as difference. So it is square of the difference of two numbers a and b. And we know what is its expansion. Its expansion is a square minus 2ab plus b square. And what is the difference between the two identities? The difference is of only one minus sign. If you have got plus in the bracket, then the middle term will be plus. If you have got minus in the bracket, the middle term will be minus. The first and the last term are always positive because they are squares, and square can never be negative, my friends. Okay, so these were the first two basic identities which we require to know and remember while solving questions in trigonometry. The third one, a plus b multiplied by a minus b. We know what is it. It is a square minus b square. The fourth identity, which is in the form of cube. See what is it? It is a plus b the whole cube. Again, you can say it is cube of the sum of two numbers. And the below one is cube of the difference of two numbers. Now when we are dealing with cube, my friends, we have to be very, very careful and see what care we have to take. First of all, let us see what is its expansion. A plus b the whole cube can be expanded as a cube plus 3a square b plus 3ab square plus b cube. If you remove 3ab common from the two middle terms, then we get a cube plus 3ab. We have removed common because you can see the 3 is common in both the terms. A is common in both the terms as well as b is common in both the terms. Therefore, we can remove 3ab common, and what is left inside the bracket? It is a plus b, correct? Plus b cube is as it is. Then in a minus b the whole cube, when we will expand it, see what's the difference, my friends. The difference is a cube minus 3a square b plus 3ab square minus b cube. Now you will see that when the bracket contains minus sign, that is when we are taking cube of difference, that time wherever the power of b is odd number, for example, you can see here the power of b is 1. Although we know that we never write down 1, but it is always there. So here the power of b is 1 and here the power of b is 3. So wherever the power of b is an odd number, there the negative sign appears. And where the power of b is positive, here you can see b square. It is an even number. So wherever the power of b is an even number, there you get the term as positive. So you have to be very careful while putting negative sign and positive sign before the coefficients. Correct, my friends? So in this way we can remember it. Now, when you remove 3ab common, as we had removed in the earlier case, in the same way, if I remove 3ab common over here, I get a minus b inside the bracket. So now why a minus b has come inside the bracket? Because when you remove negative sign common, this positive sign becomes negative. So this plus has become negative when we form bracket. When you open the bracket, you will again get the same terms. Why? Because minus into minus will become plus. In this way, we can remember a minus b the whole cube. So these were the first 5 identities that we require. Now let us move further. Very, very important identities that we will be using very often in solving questions in trigonometry. And they are a cube plus b cube. Now you wonder, sir, what is the difference between a plus b the whole cube and a cube plus b cube? See friends, this is called cube of the sum. That is, we have taken the whole bracket and then taken the cube. Whereas here, it is the cube of individual terms and then added. So therefore, here it is called as sum of the cubes. And this is called as cube of the sum. I hope my language is very clear, very specific, and everybody must be able to understand what am I speaking. Again I repeat, this is called as the cube, correct, individual cube, and we have taken its sum. So sum of the cubes, and this is called as cube of the sum. Similarly, this is called as difference of the cubes, and this is called as cube of the difference, correct? So now let us see the formula for them. First of all, a cube plus b cube. One formula that all of us know, we have been learning from our lower standards, that is a cube plus b cube can be written as a plus b into bracket a square minus ab plus b square. Whereas a cube minus b cube is equal to a minus b into bracket a square plus ab plus b square. These two formulae, one for a cube plus b cube and the other one for a cube minus b cube, these two, the first ones where I am putting a tick mark, you can see over here, these two are called as factorization identities of a cube plus b cube and a cube minus b cube. I'll repeat, they are called as factorization identities. Why factorization identities? Because you can see that you have expressed a cube plus b cube in the form of a product. Product means multiplication of two brackets. A cube plus b cube is equal to a plus b multiplied by some other term, that is a square minus ab plus b square. So this is called as factorization because you have converted a sum into a product, into a form of factors, correct? Same here also. You can see a cube minus b cube is equal to a minus b multiplied by a square plus ab plus b square. Once again, you can see that you have converted a difference. You have converted a difference. You have converted a binomial into a product, and therefore this is also called as a factorization identity. Now see the difference. When plus appears over here, you can see that all the terms are plus except for AB. AB is negative. Whereas when we are dealing with negative sign, a cube minus b cube, that time all the terms are positive except for this b in the first bracket. So the sign of b in the first bracket is positive when a cube plus b cube is considered and ab is negative. And in the second case, the sign of b is negative whereas ab is positive when we are considering a cube minus b cube. Rest all the terms are always positive. For example, this a never changes, the sign of a square never changes, and the sign of b square never changes. It is only b and ab whose sign interchanges when it is a cube plus b cube or a cube minus b cube. Now going further, I am going to explain you a very, very interesting identity, that is again a cube plus b cube only but in a different form. What is it, my friends? We can also write down a cube plus b cube as a plus b the whole cube minus 3ab into bracket a plus b. and I can write down a cube minus b cube as a minus b the whole cube plus 3ab into bracket a minus b. Now you will wonder, sir, from where do we get this identity? Because we have never gone across this identity. Now it is very simple, my friends. I will show you how I got this identity. If you see this identity properly, my friends, where we had taken a plus b the whole cube is equal to a cube plus 3ab into a plus b cube. Now what we have done? Keeping a plus b the whole cube as it is, we have taken this entire term from right hand side to the left hand side. And as you take this term from RHS to LHS, you know that the sign will change. So this plus sign becomes minus, and hence you get a plus b the whole cube. See here, a plus b the whole cube. This entire term when I take over here becomes minus 3ab into bracket a plus b. Don't touch this sign because this sign is inside the bracket. That doesn't get converted to minus when we change the side. It is only this sign which will get converted from plus to minus when we change the side, because this is one term for me. This entire thing is one term. So when I take this entire term from one side to other side, this sign will change. Correct? Not this one. Are you getting all of you? So therefore, now you can see that once I shift this from here to here, only a cube plus b cube is left. Therefore, I can say a cube plus b cube, this one, a cube plus b cube is equal to a plus b the whole cube minus 3ab into bracket a plus b. Got it clear? In the same way, for a cube minus b cube also you can see what we have done, friends. See here, we have shifted this 3ab into bracket a minus b from RHS to LHS. On the LHS, what we had got earlier? On the LHS, we had got a minus b the whole cube. So when I take this entire term from RHS to LHS, this minus sign gets converted to plus, and hence we get a cube minus b cube is equal to a minus b the whole cube, this one, a minus b the whole cube, and when this entire term comes from RHS to LHS, we get plus, because it was minus over here, so it got converted to plus 3ab into bracket a minus b. In this way, we get the identity for a cube plus b cube other than the factorization identity, my friends. Therefore, from now onwards, we have got two identities to remember in case of sum of the cubes and difference of the cubes. We have to practice these identities very well before we start the questions. Now, another thing that you can see over here is that how to convert or how to interchange the terms when we are dealing with minus. Friends, if it is plus, we don't have any problem. You can always write down a plus b as b plus a. Correct it is? But I cannot write down a minus b as b minus a directly without making any change. So what change we have brought over here? To convert a minus b into b minus a, we require to remove a negative sign outside the bracket. So if you want to convert a minus b into b minus a, that is to reverse the terms, we require a negative sign outside the bracket. When you open the bracket, friends, you will get the same thing, a minus b. Correct? Now you will wonder, okay, why this point is important. Friends, many times you will see that in questions based upon proof, sometimes we will require to convert maybe sine theta minus cos theta into cos theta minus sine theta, depending upon the situation. There, if a student does not know how to remove that negative sign common, the student will get stuck up over there and he or she will not be able to solve the questions further. And therefore, you require to know how to convert a minus b into b minus a or any two terms which are related with minus sign. Coming next. Now, a square plus b square. You will wonder, sir, a square plus b square, we don't have any identity based upon them. You are very true. We don't have any identity for a square plus b square. But we can make certain modifications, friends. For example, see identity number 1, where we had got a plus b the whole square is equal to a square plus 2ab plus b square. Now keeping a square plus b square where they are, if I take the term 2ab from RHS to LHS, what I get? I will get a plus b the whole square minus 2ab is equal to, what is left of the RHS? We are left with a square plus b square. So in this way we can write a square plus b square as a plus b the whole square minus 2ab. You can see from here a plus b the whole square minus 2ab. Similarly, to get a square plus b square, we can also use identity number 2. That is, this is a minus b the whole square. If I shift this minus 2ab from RHS to LHS, I will get plus 2ab is equal to, what is left of the RHS? A square plus b square. So a square plus b square can be written in two forms. Either a plus b the whole square minus 2ab, or a square plus b square written as a minus b the whole square plus 2ab. The adjustments we have done in the identities, identity number 1 and identity number 2. Now interrelationship between these two identities. How to interrelate a plus b the whole square and a minus b the whole square? To interrelate them, the relation is this one. A plus b the whole square can be written as a minus b the whole square plus 4ab, and a minus b the whole square is equal to a plus b the whole square minus 4ab. So if plus appears on the LHS, you can see plus appears here also. If minus appears over here, then minus appears here also. This is the way to remember these two identities. Friends, we are going to use these identities many times while solving problems in trigonometry. So this completes our segment of understanding all the identities which are useful in solving questions in trigonometry. Thank you, my friends. Take care.